BPT, basic proportionality theorem. Okay, then it is called in both of these ways, so you guys can remember in both the ways. So let's look at the distinct names that or words that we will use over here, which is not used in your day-to-day stuff. If a line is drawn parallel, okay, parallel is something not new but still to one of the sides to intersect to other two sides in distinct point. The other two sides is divided in the same ratio. So let's understand all of this first. So parallel. So when do we tell two things are parallel? So if I have anything, two lines or two pen, they're said to be in parallel if to whatever length you extend, they will never meet. Okay. Example of something meeting is over here. So these two lines, as of now, they are not meeting. I agree. But if I extend them, 1 minute, I'll extend them. So if I extend this line, right, and extend this line, they're meeting. While if I extend this line and extend this line, they will never meet, right? So line 1 is said to be parallel to line 2. Symbolically represented as arrows. These two lines are parallel. Okay. Next, intersecting. This is the point of intersecting of line 3 and line 4. Intersecting means they are meeting at a point. This two, line 1 and line 2 will never meet. Distinct. Distinct means, let me show you with, yeah. So here we have this point A and point B are said to be distinct. What does it mean? They're two different points. You and your friend are distinct to look at. Different to look at, basically. Same ratio. So two ratios are said to be same if, example, 2 by 4 is said to be equal to 4 by 8 because in their simplest form, both of them are equal to 1 by 2. Okay, I hope you guys understood the words. If not, you go rewind the video and have a look. So let me, because I'll need the space, right? Now, as a whole, let's read the statement. If a line is drawn parallel to one of the sides of the triangle, okay, first thing is we need a triangle and we need to draw a line, okay, to one of the sides of the triangle. Let me call this side as side 3. Okay, so this is side 1 and this is side 2. So if the line is drawn parallel to one of the sides of the triangle to intersect the other two sides, so side 1 and side 2, it is intersecting which line? This parallel line P of P1. So this is parallel to the third side. The other two sides in distinct points. Yes, it is meeting at distinct point A and B. The other two sides are divided in the same ratio. So if I call this as PQR, right? PA by AQ will be equal to PB by BQ. So this is something that we need to understand with example. So if I call this entire length side 1 as 10 is said to be 10 centimeter. If PA is say 8 centimeter and AQ is 2 centimeter. Okay. And if this entire length is 20 centimeter, then PB should be equal to 16 and BR should be equal to 4 centimeter. How did I tell that? Simple. What the theorem tells is PA by AQ should be equal to PB by BR. The ratio of the sides, okay, the sections have to be equal. As simple as that. So are they equal? As per this diagram, 8 by 2 is equal to 16 by 4 is what I'm claiming. This is 2 ones are 4s are, so 4 by 1. And the second term is 16 by 4, that is also 4 by 1. Yes. So what we have done is correct. This is what the theorem talks about. Let me take a bit complicated example. Like say this is again 10 centimeter. The theorem tells that, okay, if I have a line drawn parallel to the third side intersecting the other two sides in distinct points, okay, all that statement is correct. Then if this ratio, like say in this case, this is 7 by 3 by 3 by 7, this 2 will be in the ratio of 3 by 7. Of course, the ratio will be same, but the values need not be same. So I'll take a bit complicated number, 14 centimeter. So this side have to be in the ratio of 14 centimeter. So those values will be, I've pre-calculated this. This is, okay, 4.2 centimeter, and this is 9.8 centimeter. Those will be your length. That is 3 by 7 will be equal to 4.2 by 9.8. Is it so? I mean, is this equal to 3 by 7 itself? Let's try it out. I'll write this as 42 by 98, and we have 14 that is common. So, I mean, not 14, sorry, 2 that is common, 21 by 49, right? And 7 that is common, 7, 7 what's that? 7 3s are 7, 7s are, yes, they are the same. So this is what the theorem tells. So in general, right, the same thing, parallel to the third side and dividing the other two sides in two distinct points, then this is A centimeter and this is B centimeter. Okay, the ratio of this, that is A by B. And if this is M centimeter and this is N centimeter, will be equal to AQ by QC. That is A by B will be equal to M by N. That's what the theorem tells. As simple as that. Right? So my plan is to do numericals and corollary and converse of this theorem. And proof of all of these theorems, I mean, whatever is required, will be done at the end of the Q&A. Okay, we'll do certain examples, certain questions, and then we'll look into the proof. If you want to see the proof, that's left to you first. You want to see the proof and then do this, left to you. But that's my flow. I'm just telling you guys.